In this video, I will show you how to use the properties of angle bisectors and midpoints to find unknown values. Okay. So when you're talking about bisectors or midpoints, sometimes you're going to be given a half and another half. When that happens, you know that a half will equal a half. Sometimes you're given a half and a whole. A half does not equal a whole, obviously, but two halves will equal a whole. So if they give you a half and a whole, you will set it up as two halves equals a whole. So looking at this picture, we're given that AB is a bisector. So this is splitting everything right down the middle. That means we have a half and a half. So a half will equal a half. So we should be able to do 3x should be equal to 2x plus 25. Subtracting 2x from both sides will give us x equals 25. All right, that's helpful. I should be able to substitute 25 in for x right there. 3 times 25 is 75. And this is angle CAB. So angle CAB will be 75 degrees. Okay, now this other angle is DAB. That's the other half. So this should also be 75 degrees. Okay, that leaves angle CAD. But understand that angle CAD is the whole. So I'm just going to add these up. But 75 plus 75 is 150. All right, so there you go. They did not give us a picture this time, so we need to draw the picture ourselves. M is the midpoint of segment AB. All right, so whenever they give me a statement like that, I always start with the second part first. All right, first draw segment AB, which might look like this. And then M is the midpoint. So here's M right here. Now, AB is 4x. Okay, so here's AB right here. AM is 3x minus 12. Notice I'm color coding this to make it easier to follow. So AB I did in red, AM I'm going to mark in purple. So, do I have a half and a half, or do I have a half and a whole? Clearly I have a half and a whole in this case. So that's why I'm going to go 2 halves equals a whole. All right, I'm going to set it up like this. 2 halves equals a whole. Now, the half is AM, the purple. So when I do 2 halves, I'm going to do 2 times the purple. 3x minus 12, that's the half. Equals the whole, which is red, that's going to be the 4x. After a little distributive property, we will have 6x minus 24 is equal to 4x. Now, whenever I see the x's on opposite sides of the equation, I need to get those together. So sometimes I might subtract 4x from both sides. But that confuses students because they don't know what to do when there's nothing left. All you really have to do is put a zero there. But a lot of students find that confusing. So probably it will be less confusing if I subtract the 6x. All right, that's going to give me a negative number, but that's okay. So I will get negative 24 is equal to negative 2x. And then when I divide both sides by negative 2, that's going to leave me with x is equal to positive 12. So x is equal to 12. All right, now I should be able to substitute that in. So if I want to find AM, which is purple, I'm going to substitute 12 in right here. So that's 3 times 12 minus 12. So that's going to be 24. Okay, maybe I should just show that real quick. 3 times 12 minus 12. And so if I want to find AB, okay, that's here in red. Well, maybe I won't skip this. MB is right here. MB is the other half. Right? AM is half, MB is the other half. So these two should be congruent to each other. So if AM is 24, then MB is also 24. Now AB is the whole thing. So it should be double this, which is 48. It should also be what I get if I were to plug 12 in right here. All right, so that's a nice way of checking your answer. If we look at 4 times 12, that is 48, which is what it should be if we add these together. All right, number 9. Again, they did not give us a picture. AB is the angle bisector of angle COD. Whenever they give me a statement like this, start with the second thing first. All right, start with angle CAD and then draw the bisector. Okay, so all right, so here's CAD. So there's angle CAD. Now AB, segment AB is the angle bisector. So I'm just trying to put this in the middle. So that is the bisector. So that means that this angle and this angle should be equal. Okay, let me undo that for now, but just keep in mind that those should be equal. So what is next? Angle CAB. All right, let's color code this again. All right, angle CAB is this angle over here. Okay, so this is angle CAB. Okay, now angle CAD. Okay, angle CAD is this angle right here. So I'm going to mark that in green. So angle CAD is doing like this. So is this a half and a half, or is this a half and a whole? Well, this is a half and a whole. You can plainly see. So that's why we're going to set this up as 2 halves should equal the whole. All right, so 2 halves. The half is the small angle, the angle CAB. So that's why I'm going to put 5x minus 3. The whole is angle CAD. So that's going to be 7x. After distributive property, we will have 10x minus 6 is equal to 7x. And wow, again, I need to get these x's together. And normally I might subtract 7x from both sides, but that will leave 0 over here. Students tend to find that confusing. So instead, I'm going to subtract 10x from both sides. So that will leave me with negative 6 is equal to negative 3x. And then when I divide both sides by negative 3, that'll give me positive 2 for x. Okay. So if I want to find CAB, which is up here in red, that's 5x minus 3. So that's going to be 5 times 2 minus 3. Well, that's just 10 minus 3, so that should be 7 degrees. All right, how about angle DAB? Okay, DAB is going to be this purple angle right here. This is angle DAB. And that's the other half. Okay, so if the first side is 7 degrees CAB, then DAB should also be 7 degrees. And then, of course, CAD is the whole angle, which should be double this. So that's going to be 14 degrees. All right, which should also be what I get if I were to plug in 2 for x right here, which would just be 7 times 2, which is also 14. So that is a way of checking your answer.